Hi everyone, I am going to apologize in advance if there's a weird echo or you hear lots of background noise. We're having a little bit of a problem today with the recording devices, I guess they are. So I'm going to try to speak very quietly and not move around too much, although we're doing manipulatives today, so that may make a lot of clunking. So if you need to, you might have to turn down your volume or something like that. I apologize. I did test at this level in my office and it seems okay. So hopefully you don't get any really weird echoes and reverberations and stuff like that. Okay, here we are, week 8, day 1, and we are working on Algebra Tiles and Algeblocks. So I keep on telling you that you need to get yourself a set of Algebra Tiles. Hopefully most of you have by now. We're going to go ahead and start in on this. I'm actually going to show you the Algebra Tiles quickly, and then I'll move on to Algeblocks, which are a little bit different, and I'll explain the pluses and the minuses and the differences as we go along. Okay, so what you're seeing in front of you are Algebra Tiles. These things, if you just took a little bit of time to explore them a little bit, you'll see that whether I have this large square here, or the longs here, if you compared to these to base 10s, what you know of the base 10 blocks, these would be like a flat, this would be like a long, and these would be like a single, right? Okay, so whether I'm looking at those, at the longs, or at the units, I see different colors. So for the large squares, I see a red and a blue. In the longs, I see a red and a green, and in the singles, I see a red and a yellow. What they all have in common is the reds. So interestingly, whenever we're dealing with algebra tiles, it's just a known convention that whenever you see red, that means negative. So just some stuff to think about. If we start out with these little building blocks, these units, as our ones, then we could just talk about regular old counting, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, and that would be a positive 8, right? 1, 2, 3, 4, 5, and that would be a negative 5. And those are just numbers, so anytime you see integers or whole numbers or natural numbers, we're used to working with those as, you know, this type of number, but even that is an abstraction. So whenever you see the number 8, for instance, that to us as adults, we kind of go, oh, 8, I know what that means. But to kids, as they're really, really young, they're learning how to count, they're learning how to add, subtract, things like that. They're just getting started on all of this. They're thinking, oh my gosh, I don't know what the 8 is. So probably they've had some experiences, right? 8 pieces of candy, 8 marbles, 8 toys, 8 dolls, 8 blocks, whatever, okay? So eventually, in their minds, the idea of having 8 separate individual items that they can count turns into, oh, I know what an 8 is, okay? We all know negatives come later, right? Whenever they're doing their, I would call it like Piaget's advancement of their psychology. Yeah, their psyche, okay? As they advance, they go from positive numbers to sooner or later they can understand negative numbers. So now maybe I understand what it means to take away 5 of my pieces of candy, right? Okay, so they also start coming out with this idea of, hey, I had 8 pieces of candy, now I have 5 of them taken away, so sooner or later I'm going to figure out what that means for me is I still have 3 pieces of candy, right? So there's this little process that we're going to go through. You're going to need it as we go into Algebra Tiles and Algeblocks, and it's called making a zero pair. And what that means is I can make a zero pair by adding a positive 1 of anything, and right now we're just talking about numbers, right? But I can add a positive 1 of anything to a negative 1 of anything, okay? So I'm adding these together. I've got a positive 1 and a negative 1. So a positive 1 and a negative 1, if I kind of put those together or pair them up, that's the word pair. If I can pair a positive of anything with a negative of the same thing, then I see what happens there. Plus 1 minus 1, well, that will zero out, right? Okay. Or a lot of people say it cancels, but we try not to say that word too much around here. So it'll reduce out, or it'll zero out, or however you want to think about it. And in this next unit of stuff, we're always pretty much going to talk about zeroing them out, because a positive and a negative gives me a 0. So if those go away, and then I have another pair, a positive and a negative, that will zero out. And then these, another pair zeroes out. And then here, another pair zeroes out. And then here, another pair zeroes out. Then what do I have left over? Yeah, the positive 3, right? So what we've just shown is plus 8 plus a negative 5 gives me plus 3, right? Positive 3. And in Algebra Tiles, we're going to recognize that these are positive because they're simply not red, okay? In Algebra Tiles, all of the negatives are reds, okay? So because these were yellows, they were not flipped upside down. As you get your Algebra Tiles, you can see that. If you have the commercial ones, they'll be two-sided. If you make your own, you'll make your own yellows and reds, or however you want it to be. Okay, but as I start looking at that, I say, hey, what really happened in here is that I had, and I'm gonna split this 8 up a little bit. I had a positive 3, and I had a positive 5. I had a negative 5. I'm adding all those together, and I'm pairing them up. So the positive 5 and the negative 5 paired up and ended up as a 0 pair. This gives me 0, right? Okay, so as those go away, they pair up, they go away, I'm not going to see them anymore because I actually literally, with kids, take them off my piece of paper, right? And I'll be left over with a plus 3. Okay, and I'm going to tell you the reason why. There's a couple of reasons I've asked you to get Algebra Tiles instead of Algeblocks. One is they're way cheaper. Okay, you can get a set, a one-person set of Algebra Tiles for less than $3 on Amazon or through ETA. A single set of Algeblocks is probably going to run you around $60 if you can find it all by itself. Usually you have to buy a classroom set, which I think is 6 sets or maybe 8 sets, and that's not even a classroom set. They think that you can put 3 or 4 kids in one set, but that doesn't work very well. But however many sets of Algeblocks that is $240. The last time I purchased any. So they're not cheap. So that's the first reason I told you to get Algebra Tiles instead of Algeblocks. And the second reason is because they have this red thing for negatives in it, so it's kind of nice. And the third thing is, quite honestly, you're going to see them again. So if you're working in the middle school, actually, I'll show you with Algeblocks where we can take those from very beginning arithmetic type stuff all the way through kind of, Algebra 1, Algebra 2 type things. So, but in particular in the middle school area, you're going to see these, you're going to work with these. And if you're going to be a high school teacher, that's actually one of the first things I learned whenever I was teaching Algebra 1 in high school is how to work with Algebra Tiles, because it's a requirement on the EOC for Algebra 1 that the kids can do Algebra Tiles and that they understand, they can look at a picture and see what it means. So if you're going to teach them that, you've got to understand that, right? I've also seen some questions on the 7 through 12 state board exam that everybody has to take before they get to be a fully certified teacher, and they had Algebra Tiles on there. So I want you to see the Algebra Tiles and be fluent in them, because they're not just going away as soon as you get out of this class. You're probably going to see them again in your futures as public school teachers. So I can almost guarantee you'll see them at some point. Okay. So that's kind of the idea behind the integers there, the units, the little bitty square guys, just a 1. He's worth 1, okay? If he's red, he's worth -1. All right. So that's the idea behind those guys. And then we have these other two pieces. So I want you to explore them just a tiny bit. Compare them, see what's going on. For instance, if I line up along the sides of this square, then I see, well, first of all, I see he really is a square, and his length is 1 green, and his width is 1 green. So because he has the same length as he does width, that tells me he's a square, right? Okay, so he's a square, and he's however long this guy is. Now, these guys, these longs here, they have a width of 1, okay? So it would be kind of nice if somehow they lined up with the units, so we could say, hey, that green guy, he's worth 5, or hey, that green guy, he's worth 6, or something like that. And what we see is, when I get them lined up, they don't quite match up at the end, okay? So he's a little bit bigger than 5. He's a lot smaller than 1, or a lot smaller than 6, right? And so if it doesn't match up exactly on the ends, I can't give him a numeric value, which the creators of this did on purpose. Okay, it's not going to exactly line up, but you'll notice the square guy does pretty much, I mean, as much as the manufacturer can make it happen. The square guy does line up that he's this green by this green, right? So what we do is we say, oh my gosh, I just need to give him a name. And so by convention, we pretty much always say that, let me come back here, the small square, also called the unit, is worth a 1. The long rectangle, sometimes he'll be called the long. We don't know how long he is. He's a little bit bigger than 5 units long. We're unknown, so we're going to call him an X. We don't know what that value is. So when we don't know something's value, normally we call him our unknown, and he's my X. So then think about that blue guy there. He's an X times an X, large square. If you were thinking about it as if it was a base 10 block, you might call him a flat. But as soon as we get a name for him, we'll have an actual name for him. He's an X times an X, and we know length times width on a rectangle or a square is the area, right? So inside of there, inside of this blue guy, the area of him is X times X, or X squared. Okay, so these are the things we're going to call these from now on. The yellow guy will be a positive 1. The red small square will be a -1, right? The green long rectangle will be a positive X. The red long rectangle will be a -X. And on the square side of things, the large squares, the blue large square will be an X squared, and the red large square will be a -X squared. So that's the other lovely thing about Algebra Tiles that most people like a lot, is that they actually have a piece that registers negative. Okay, when you see red on Algebra Tiles, you should be thinking that's negative. Okay, so we don't have to wonder or worry or whatever. We're always thinking to ourselves, whenever I see a red in my Algebra Tiles, that's a negative. So what I'd like for you to do is I'd like for you to look at a couple of these configurations. I'm just going to throw up on the board here, or on my paper, and I'd like for you to tell me what is being represented on your screen. So you should be able to come up with some kind of an expression here. It's not an equation yet because I don't have it equal to something, but I should be able to come up with an expression. So I've got what? 1, 2, 3 of those guys, and we're going to call it what? 3x squared. Okay. And I've got, oh, let's not do 3 of those. Let's put an extra guy out there. Sorry, I didn't realize that I had the same number. Okay, so we've got 1, 2, 3, 4 of those green guys, and I'm going to call them 4x, right? And are they positive or negative? They're positive. Okay, and then all of these red units, that tells me that that's negative. And then I just have to count them, right? So 1, 2, 3, 4, 5, 6, 7, 8, negative 8, okay? So what I'm got displayed for us here is a polynomial that's 3x squared plus 4x minus 8, okay? So I can show you where we can display lots of stuff. Do one more. I'll put it up here. And hopefully as soon as I have it put up here, you'll be able to tell me what that is. It shouldn't be too terribly difficult. It's not meant to be too terribly difficult. Just recognizing what's in front of you on the board. Okay, if I could write today. Negative x squared plus 2, or I'm sorry, minus 2x plus 4. And by the way, you'll learn as I go. As I put things on the board, I would call that adding. Okay, so an alternative for this could very well be negative x squared plus a negative 2x plus a 4. And so people start seeing how, hey, I put on the board a negative x squared. I put on the board, I added onto the board negative 2x, and then I put on the board a positive 4. So they start seeing, and technically it would be plus a positive 4, right? They start seeing that rule that comes out that we kind of, again, take it for granted as an adult. If I have a positive next to a negative here, if I'm adding a negative, I know that's the same as subtracting, right? Or if I see technically this is a positive 1 times a negative 2x, right? So positive 1 times negative, so a positive times a negative, I get a negative. Oh, we just start dropping that off and using a negative, right? So that's one of those things that adults start taking for granted, and then whenever we go to teach kids, it's difficult for us as adults to go, what are they missing? I don't understand why this is so hard for them, because it's clear to me. But for kids, they're like, no, you added a negative, why is it the same as subtracting? So start coming up with thoughts on what that is, and sooner or later I think we'll hit some stuff in class. I hope we'll get that far, where we'll talk about, what exactly is going on there. And again, here, a plus a positive 4, adding on a positive 4, well, we know that's the same as just adding. And in your multiplication rules, that would be a positive 1 times a positive 4, or a positive times a positive gives me a positive, right? So sometimes adults have those little cheats that they say, oh, if they have the same sign and I'm multiplying, then it's a positive. If I have the same sign, or I have opposite signs and I'm multiplying, then it's negative. But really kind of think about what's going on in the background with that. Okay, so we kind of see what's going on with these tiles. The next step is that we want to do stuff with them, right? So what you'll end up seeing is I'll put up some expressions and I'll say, okay, can you do something with those? And then we'll find out exactly what that looks like. So the first thing that we'll see, and I'll use these real quick with the algebra tiles, but then we'll switch to Algeblocks here in a minute, because Algeblocks are a little more flexible than the algebra tiles. So I'm going to show you the Algeblocks, but for your test number 3, I didn't want to require you to buy Algeblocks, and that's why you're doing algebra tiles. So there's some stuff I can do with Algeblocks. I'll show it to you as I go along. that I can't do with Algebra Tiles, and that's why those are preferred by some people for certain things. But for this one, we see this is the Algeblocks basic mat. Now the Algeblocks basic mat, what it does is it's just a positive on one side and a negative on the other. So it actually tells the kids when they see it, everything on this side is a positive and everything on this side is a negative. So as they put things down, for instance, if they have put a positive on there and they put a positive on this side, but it's on the negative, that automatically makes it a negative, right? So that's something that Algeblocks don't have. They don't have the red. Like for us, we would say, oh, for the Algebra Tiles, just flip one, right? But Algeblocks aren't going to have the red. Algeblocks are all the same. So they're not going to see that going in there. But real quickly on this, I just want to show us that zero pair rule that I was trying to show us earlier. So here we go. If I look at these, again, they're all positives, but some of them are on the negative side. So the negative side of the mat kind of will cause things to happen that make things negative because they're in the negative quadrant or the negative side here. Later we'll have quadrants, sorry. Okay, so if I was thinking about this, I would think I had a positive 2 that I put on the mat, and I had a positive 3, but I made them negative, so I added on negative 3. Okay, but the idea here is the 0 pairs. So what the heck's happening with the 0 pairs? I'm going to add a positive 1x to what ends up being a negative 1x. They're going to pair out and go away, right? And here's a positive 1x and a negative 1x. Again, they pair out and go away. So this ends up with just a negative 1x. So what I'd like for you to do is think, what was the math that was involved in that? Okay, on the one side I had negative 3x, right? And on the other side I had a positive 2x. So negative 3x plus 2x. What the heck's going on there? Now this is adding, and they have opposite signs, right? So for us as adults, we kind of go, oh, when you're adding something that have the opposite signs, you're just gonna, what's that old rule, dang it, subtract and take the sign of the bigger number, right? That's the rule. So 3 minus 2 is 1x, because they were x's, right? But because the 3 is bigger, I take the sign of the negative number, right? So I've got negative 1x. That comes about here on the tile or on the mat, looking at it, okay, from these guys pairing up, right? Those paired up, those paired up, those are 0 pairs. So positive 1x, negative 1x, that adds up to 0. Positive 1x, negative 1x, that adds up to 0. So those pretty much go away, and what am I left with? Negative x, right? If it was just Algebra Tiles that I was working with instead of Algeblocks, like say on your exam number 3, you would represent this like this. Negative 3x plus 2x, and then to show it to me when you make your video in a few weeks, I know it seems like a long time. We're still working on test 2 here, right? But test 3 is going to be here before we know it, because test 3 is due before Thanksgiving, guys. So guess what that means? I have to get you some Algebra Tile stuff now so you have time to work on your test number 3 video, right? It's a video, you're going to turn it into me, so I got to show you all this stuff so that you will be able to do some problems I send to you and make a video and send it back. Okay, so here we go. 0 pair. 0 pair. Does everybody agree? Positive 1x, negative 1x equals 0. Positive 1x, negative 1x equals 0. And then I'm left over with a negative 1x, right? Okay. So that's kind of, right here I have the abstraction, what we would normally see going on, right? And then what we see with the Algeblocks or the Algebra Tiles is that's what the kids would do while they're still trying to get to this point, because they don't know yet what the heck is going on here. Okay, so one more of those. Just so that we all know, if you'll write down what is it that I'm demonstrating with the blocks here. Okay, I think that that is 2x squared plus negative 1x squared. Does everybody agree? Positive 2, x squares, negative 1, x squares. So again, we have that old rule that says they're opposite signs. So I'm going to subtract and take the sign of the bigger one. But here, with this, if I'm a child, I know, hey, there's a positive 1x squared and there's a negative 1x squared. Those are going to zero out and go away. And what am I left with? 1x squared, right? And we know that sooner or later I can start leaving off the positive, and sooner or later I don't have to write the 1, right? Okay, so those were, what if they were the opposite signs? Well, what if they were the negative, or the same signs? So what if I said, I put down this group, that's one group, and then I also put down on the mat this group. Okay, so what am I representing? Over here, this group is negative 4x. Everybody agree? And then I added to it, I also put down, so in addition, I put down another negative 2x. And if you like extra parentheses, you can put extra parentheses, it doesn't matter. So this one's actually pretty nice for the kids because all they have to do is kind of group them together because nothing's zeroing out, right? And say, hey, there's negative 4x and there's negative 2x, and that's a total of negative 6x, right? Okay, and that lets me know why that old rule is, oh, when they're the same sign, negative and a negative, when they're the same sign, you just add them all together and then take whatever the sign is. Because nothing changed as far as signs go, right? Whenever I added those together, they just all kind of grouped in there, okay? So one more of these, and then we'll move on a little bit. Okay, this is my first group. And then to that, I'm going to add that group. So thoughts should be going through your head right now. Are those ones, or are they x's, or are they x squares? And how many in each group, and are they positive or negative? So hopefully all those things are running around in your brain. So I've got 7 in the first group, and they're all positives, right? Okay, so plus a 7. And then I added to that group 4 in this group, and they were all positives, so plus a 4. And so all together again, they're all the same sign, so I don't have anything that I'm going to pull out and make an opposite sign or zero pairs or anything like that. They're all positives, and all together now the kids can just count and say, okay, there's a total there of 11. All right, so that's kind of what the adding and the subtracting looks like, depending on what situation you're given. We know that we have other operations though, right? It's not just about adding and subtracting. So I'm going to show you, I'm going to switch from Algebra Tiles to Algeblocks, and then I'm going to show you what it looks like whenever we start doing things like multiply and divide. So let me swap for you. Here are the Algeblocks. Again, here's this mat. It's the basic mat that we had before. I'm going to show you some stuff about the Algeblocks. This is just kind of my intro video to show you all the different stuff that's going on. Actually, I'm sorry, before we get to the mat, let me just show you these Algeblocks. So I'm going to show you all the different stuff that goes on with the Algeblocks. So you can see right off the bat, I hope, first of all, there's a color difference, right, but we'll deal with that. But the Algebra Tiles were flat, right? They're really skinny. even whenever I had, like, say, the x here, its width is a 1, but its length is an x, right? So this is just a 1x. It has no depth to it, basically, right? I mean, it's only as thick as it has to be to actually be a physical manipulative that I can play with, right? But here, if you can tell, look at that. This is a three-dimensional cube, right? So it has length, width, and height, or length, width, and depth, depending on how you think about it. Okay, so these are still my units. So Algeblocks. They're still my units, but now I have a small cube, right? Earlier it was a small square. That was my algebra tiles. Okay, so now with the Algeblocks, they're a small cube. It's still the smallest building block that I have, so I'm still going to call him a 1. He's still my unit. It's just that now I'm dealing with a three-dimensional unit, which is kind of neat, actually. Okay, and then I have several other pieces, so I'm going to just put them up here so we can play with them. I'll get a couple of other guys up here in a second. All right, so, sorry, I'm still digging stuff out. I need one more. Looking for my extra guy. Here it is. All right. So the first interesting thing about Algeblocks is, or maybe not the first, but anyway, an interesting thing about Algeblocks is they're color-coded so that things match up. Pretty interestingly, and I'm sorry if this doesn't come across really well in the video. It's one of those things that you got to be here to see it, but hopefully I can get it across to you. So I've got some stuff. Oops, I'm missing a couple more pieces. I'm sorry, guys. Still missing a couple of pieces. I have some things in this on my picture here that are all yellows. And I have some pieces here that are all oranges. I've got my little green guys. They're the only unit that I have. So those are the small cubes. But I have the orange pieces here. And I have some interesting stuff going on here. For instance, this is just the long. This guy right here is the square. Kind of like what we had with algebra tiles, right? Let me get these out of my way. I'll come back to you guys in a minute. Okay, so I have, if I call this yellow a particular name, I have one of those things squared, and then I also have one of those things, if you can tell, it's a cube, right? It's a three-dimensional cube there. So again, he's got a length, he's got a width, but he's also got a depth that matches up, so you can see. Okay. So, if only I had a name for this guy, he's my unknown, I'm going to call him X. If this long is X, then everything else for the yellows kind of falls in place, right? This would be X squared, this would be X cubed, right? Because he's a cube. So again, this one's flat. It's not completely flat. In fact, if you looked, if you were really inspecting these, if you had them in your hand, you would see how flat is he. He's 1 unit thick there, right? So this guy is the equivalency of being a two-dimensional flat, so to speak, like we had in our algebra tiles. Totally different color and size, right? Totally different color. But he actually does have a little bit of thickness, so he is still a three-dimensional piece, okay? Whereas the others are deliberately made, the algebra tiles are deliberately made to be flat. Okay, there's good and there's bad stuff about being a little more three-dimensional. One is this means that I can do x cubed, right? I can't do x cubed with my algebra tiles because they only go to x squared. So that's kind of a plus. It's kind of a minus too, though, because it means that now we're responsible for doing the x cubed stuff. So I have yellow things, and I'm going to call it a long equals the x. The square, yellow square, is equal to, we said this was an x times an x, right? So it's x squared. And the yellow, and we'll call it the large cube instead of the small cube. But now that we have a name for him, like you can see, he's exactly a flat. That's on his length and width on each of his sides, right? So he is indeed a cube. Okay. See if that's how tall he is. All right, we're going to call him what? X cubed, right? Okay, so those are all my yellows. Well, now that I have a three-dimensional type thing coming in, I think everything else kind of falls in place and makes sense. The truly dark orange ones here, again, I've got a long kind of thing, I've got a flat kind of thing, and I've got a cube. Okay, and you can tell the cube has this for the face, right? So he's a square across the face, and he has this for his depth. So certainly those match up, right? So what do we think about it? This is the long, this is the flat of that, or the square of that, and this is the cube of that. So what shall I call my orange guy? I don't want to call him X. I already have X, a name for X. He's the yellow guys, right? So now I've got the orange, long. He's going to be what? Y. Okay, and then I've got the orange square. He's going to be Y squared, right? And then I've got the orange cube, large cube, and he's going to be Y cubed. Okay, so the really cool thing about this for my Algeblocks is that they're color coordinated. Okay, everything that's a really dark orange, whenever you see that, or everything that has the same length in it, whenever you see a picture of it, because on the pictures they're kind of black and white, so it's hard to see. But anything that's like this has a longer length. Notice that the Y has a longer length than the X. Okay. Anything that's like that, we'll call it a Y. Okay. By the way, I didn't do this for these, but again, you can look and see the X is not going to quite line up with the units. Right? It's just a tiny bit. The X is a tiny bit longer than the green. And then the orange is bigger than the unit, than the yellow, than the X. But not by exactly one unit, because then it would be X plus 1, right? So they're really smart about the way they do this. Instead, it's by a little more than a unit. So again, you cannot exactly line these up with one of the green guys. So I can't call the yellow a 3 because he's actually 3 and a little bit more. So that's what makes him an unknown value, because I can't really very easily split one of these greens and make a partial out of it, right? So I have, because I'm counting discretely here, right, with the blocks. So I know that this orange, for instance, is a little longer than 4, maybe about 4.5, but we don't know because there's no block for that. So he's an unknown, we call him Y. Okay, so that's what's going on with those. Then I have these 3 weird colored ones, and if you can't tell, I usually call them Cheeto colored, okay? And what is going on here is basically they're supposed to be a mix of the yellow and the dark orange, okay? So if you mixed those colors together, like literally had paint that was yellow and dark orange, and you mixed them together, you would get something that's kind of a little more cheesy color, okay? More cheese, less burnt orange, less yellow. So what about these things? Well, we've got this one, and if I look at him, his width is an X, and his length is a Y. Okay, so the cheese colored ones. Okay, there's one, now this isn't a square anymore, right? This is a rectangle. And he's X wide and Y long, and we know for any rectangle, if I'm looking at what makes that guy up, like his area, it would be X times Y. So this guy is my XY piece. So you can already tell, I think, how these are a lot more flexible than the algebra blocks or algebra tiles, because not only do I have y's, not only can I go x cubed and y cubed, but I also now can talk about what if there's some combination of x's and y's. So people really like these because there are a lot more going on with them. So this is the guy who is y long and x wide. Okay, this prism here, okay, it's not quite a cube, so I can't call it that. It's a rectangular prism, is the same x times y, right? Everybody agree? That fits in there. It's the same that direction. But what's going on here with his depth? Is that an x or a y, you think? It's short, so it's an x, right? So he's an x times an x times a y, right? Because his face is worth xy. Sorry guys, we haven't quite gotten to solids yet in geometry if you're in a geometry class, but we're headed that way. So his face is worth an xy and his depth here is an x. So let's think about that. So there's a rectangular prism, and he's the small one. And he is x deep, and his face is an x times y. So what do we think about that? X squared y. Everybody agree? So I've got some weird cheesy colored stuff. And the last one here is this other, also a rectangular prism, but it's not the same size, right, as that guy is, because you can see it right here. Okay, there their faces look the same, so the face is an xy, but what about the depth of them? Yeah, this one, his depth is an x, but this one, his depth is a y, right? Okay, so they still have the same face. They still look the same from one side, but they're definitely, this guy's a lot deeper than the other one, over a unit longer. Okay, so there's another rectangular prism. He's the large one, and his face is also still an x times a y, but his depth is another y. So instead of being the x squared y guy, he's the x y squared guy, right? Okay, so you see all these different pieces coming in here. I'm looking at 42 minutes on this video, so I'm going to go ahead and say, okay, we've talked a little bit about algebra tiles. We've talked a little bit about Algeblocks. Your participation for today's grade is going to email me and tell me one difference between your algebra tiles, which we saw some up here, and your Algeblocks. And then I'm going to load up some stuff in the D2L. I'll load up the basic mats that you can see, like what we're going to use. I'm also going to load up what they call the mini mats, which are basically, like you can see, like 6 or 8 of these on one page, so that you can do different homeworks using that. Instead of this huge mat, you can turn in these little ones for homework, scan just one page for 6 or 8 problems instead of like having to print that over and over and over again, that big one. And then I'm also going to give you some basic work talking about zero pairs and just some basic adding and subtracting with algebra tiles or Algeblocks, which is the same basic thing. Okay? All right. So there you go, day 1 for week 8. And I'll be back for day 2.